Hello, my name is Faith Jean, and I will be presenting Lab 1 for Introduction to Physics 2211, which covers constant velocity of a water bottle, which I will get into on the next slide. In this lab report, I will introduce the purpose of this lab as well as key concepts surrounding constant velocity. Next, I will analyze the water bottle's motion that was recorded through Tracker. Next, I will identify the computational models and code used to replicate the real-life scenario in GlowScript. Then I will compare the observed data from Tracker to the predicted data in GlowScript. And finally, I will analyze the what if and what does it mean of my results and how that could affect the outcome. The purpose of this lab is to analyze the horizontal motion of an object. I chose a water bottle, moving at constant velocity to determine the position over time. We then use a computational model to compare to the real-life scenario by using GlowScript. And then we compare the computational data to the real-life data and identify the differences. When comparing the two models, the observed motion had a higher velocity than that of the predicted motion from the computational model in GlowScript. Key concepts surrounding constant velocity includes Newton's first law, where an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by an unbalanced force, and Newton's second law. A force applied to an object at rest causes it to accelerate in the direction of the force. This is illustrated by the two equations below, the position update formula and the velocity update formula. Because of Newton's first and second law, constant velocity is when the net force acting upon an object is equal to zero. Looking at the velocity update formula, therefore, if F net is zero, the final velocity equals the initial velocity. And through the average velocity, we can find the updated position of the object. In this lab, I selected the water bottle as the system and the rest of the room as the surroundings, as I assumed friction and air resistance were negligible as we were dealing with constant velocity. As you can see in the video, the water bottle is moving in the right direction, as I selected my x-axis to where the right direction is positive and the left direction is negative. This is also illustrated in the position as a function of time graph located in the top right corner where you can see the positive slope. In this slide, I included the code that I used in GlowScript to make the simulation. I used the starter code provided to us, and then I changed the system mass, initial conditions, time in the while loop, as well as the momentum principle. I included the link to the project on the slide as well as in the description down below. I changed the system mass, though this was negligible because we are assuming F net is zero because we are dealing with constant velocity. I changed the initial conditions to match the initial position that I was given through Tracker, and I calculated the initial velocity by choosing 2 points from my Tracker data and calculating the change in position over change in time. I set delta t equal to 0.33 because in my Tracker video it was 30 frames per second. I changed the time and while loop so the simulation would end after my water bottle reached the final position at this final time. And finally, I changed the momentum principle to match Newton's second law. Therefore, the velocity final will equal the velocity initial times the force of the ball and the change in time. And the position update formula will equal the final position equals the initial position plus the average velocity times change in time. As you can see on the right in my position versus time graph, where the blue line is my Tracker observed data, where the red line is the GlowScript predicted data, the observed results and the predicted results appear similar at lower values. However, as the time progresses, the water bottle moved at a higher velocity than the GlowScript model, as illustrated by the steeper data line. This indicates the velocity of the water bottle did not remain constant as expected, and this likely occurred due to other forces acting upon the water bottle, such as friction, air resistance, a downward slope, etc., or the slight angle in the water bottle that arose as it rolled. If I were to flip the axes, this would mean the right direction would be negative and the left direction would be positive. In this case, the position values generated by Tracker would be negative instead of positive. Therefore, when comparing the predicted data in GlowScript to the Tracker data, the graph would be mirroring each other because the Tracker data would now have a negative slope. Now, what does this all mean? Because an object moves with constant velocity, we know that the net force is zero. However, it is not possible to know how many various pushes and pulls or forces are acting upon an object such as the water bottle to add up to this net force of zero. There are many different forces present on Earth that can affect the motion of an object, so it is hard to tell which ones are in play at a particular moment, especially to the naked eye. In conclusion, in Newton's first and second law, gravity, friction, air resistance, etc. are the unbalanced forces that can cause an object at rest to move or an object in motion to speed up, slow down, or stop. Therefore, in a real-life scenario, it is not possible to achieve a constant velocity due to these forces. Thank you for your time.